There we go. Okay, on the recording, welcome to Math 20. So we're going to start with all the things we can do to change one number. And as one of the intro videos explained, this isn't how a normal textbook works. If I take our textbook and I open it, then it has chapters like fractions or percents or measurement unit conversion. And that's the way that people organize things in their brain once they know it. But when you're actually learning it, it helps to be more specific. What little math skills, what little math tricks, what little math procedures are we using now? And those are organized better by how many numbers they change at once. So the shape-shifting chapter, I don't know if anyone is old enough also to have watched Wonder Twins growing up, is all about things you don't do just a one number at a time. Once we're done with shape-shifting, then we'll go to mad science, where you are playing with things and squishing them together and seeing what comes out. We'll again talk about fractions and percentages and measurements, but the nice subtopics are all about the specific skills that happen. And they are related to each other more as putting things together in a mathematical expression than they are related to each other as this is a fraction thing or a percent thing. So that works. And then finally, our last topic at the end of the term will be things you do to an equation. You're doing the same thing to both sides of the equation and solving a problem that way. So that is our overview. Once we have done a lecture, then you'll go to homework. Again, I've put some of this in a video, but the video is now slightly obsolete, and I want to talk about it because not everyone watched that. Your job after this lecture is to go back and do the example problems. The website has all these problems for me to lecture from for several reasons. First, we don't all have the same book. Some people have the Skrine-Bittinger book. It's terribly expensive. I'm not sure how many people have it, hopefully not very many. A lot of people have the old 12th edition, which you can buy pretty cheaply. And then a bunch of people are going to be using the free online book because it's free and it's online. So since we don't all have the same book to look at in front of us, then I need to provide you a different set of problems that we all have together when I'm lecturing. There's too many of them. It is purposefully designed that we will run out of time before we go through every single example problem. And that means at the end of lecture, you will have more things to do. So you'll go back to the math topics and you'll say, today we did some rounding. And you'll say, oh, I remember this, I remember this, I remember this. And for all of them, check if you got it. And then you can toggle the answer to see, yes, I remembered this, or no, I got it wrong. And when you get to new ones, then that will be sort of your first level of homework. We didn't do number 8 in class, we skipped over it, or we ran out of time. Can I do this one myself? And then I can check my work. The next level of homework is your problem bank. And the basic problem bank, which I forgot about, silly, in the video, is just what's in your textbook. If you have the Bittinger textbook, then here is a list of all of the different sort of best of homework, so you don't waste your time. And if you had a strong math background, there's too many here. If you had a weak math background, then you might need more than this. But these are odd numbered problems, answers in the back of the book, that are organized so that you can see for our topic, here's where to go in the book and do some homework. If you're using the free e-textbook, then you can see the odd numbered answers in the back like that. Oh, this is Math 20. Math 25 meets tomorrow, Crystal. But you're welcome to spy on us.
Okay, well, good morning, David, again. This is Micha.
Good morning.
I am just joining to kind of observe, but
Sure.
I'm in your Math 25 class.
Yes.
Okay. Have a good day.
Okay. Once you've done your textbook problems, then you can also check some on the website, but this is under progress. This is something that's not done yet. I'm trying to make a nice resource for you that's not there. Then you have random problems, and finally problems to turn in. So we'll talk about that more at the end. So that's your basic goal. Like any math class, you watch the lecture and do some homework. Okay, let's get started. So we need to review place value, and mostly I want to care about which things have a TH in them. So when I have this, come on, Jamboard. Go. Okay, is that big enough to read for everyone? Because I can make it bigger if we need to. Can I go to gallery view? It's really bizarre and awkward. Okay, there should be a better way to do that. Okay, can everyone read what I was just sharing on the screen?
Yep.
Yep, okay. Okay, good enough. If you can read it, we're good. If you wanted to, you could have this open in Jamboard. If you wanted to also be able to write on it, let me know. So we have thousands, and then on the other side, tenths, hundredths, this one is going to be, oops. Thousandths with a TH. And I am not perfect at pronouncing things very carefully, but if I was, then we would always know. TH happens at the end of the ones after the decimal places. So let's just go ahead and fill this in. I wonder, can I rotate it? Looks like I can. Cool. Okay. So I can do that. Erase over there. Okay, let's just write on our others. What's the 8? Somebody call it out.
100.
Hundreds. And where would hundredths be?
4.
4. Okay, the 7.
Tens.
10. And the 5 would be tenths. 6.
Ones.
Ones. If you're from another country, you might call out units. Okay, so we have 2 more we haven't done yet. So 1 past the decimal is tenths, hundredths, thousandths. So this would be 10 thousandths and 100,000ths. One question I always get every term is, when does rounding matter for my answer for a grade? And the answer is almost never. So don't worry about that. Okay. Similar place value challenge is to put things in order. Okay, which of these is biggest and how do we know?
The comma, 20,000.
Yeah, so the biggest one is that one. It has more place values than anything else. Right? Nothing else is at least 10,000 big. Okay, what's next?
2,860.
Yeah, and I should probably, can I highlight that? No, I'm doing it wrong. I was supposed to write it smallest to largest, so I should follow my own directions. Okay, yeah, for me it's easiest to think going smallest. So the 2,860. So to do that, I'm going to start on my left-hand side and work my way to the right. So we started with the 10,000ths. This was the only one with 10,000ths. Then we look at the thousandths of the ones remaining. They are all twos. That doesn't tell us anything of bigger or smaller than the other. So I move one place value to the right. I look at the hundreds, 6, 8, 6. The 8 is the biggest, so that's the one. Finally, I move one place value more and I get to the tens, an 8 or a 0. The 8 will be bigger. And the smallest one will be there. Okay, I'm gonna stop my share for now. Everyone okay with that? Old review stuff? Okay. There's sometimes one person who gets that wrong on the test, so I thought it's worth doing, even if it's kind of easy review. Okay, this one tricks more people. Okay, it's exactly the same process. It's just, decimals, panic. So which one of these is biggest?
0.57949.
Okay, so I'm starting at the
Oh,
biggest
okay.
digit. They're all 0 in front. That doesn't help. Then I will go to the
9 1.
tenths. They're all 5s. That doesn't help. Then I will go to the hundredths. They're all 7. That doesn't help. Then I'll go to the thousandths. There's a 4, a 9, and a 9. So these two with the 9s are our biggest candidates. Go to the next one, a 0 and a 4. So this one wins because of that 4. Everyone follow me?
Mhm.
Some nods? Okay. So our biggest one was the 0.57949, and the next biggest one also had, whoops, 7. Oh, I missaw it. Okay, never mind. So there was no other one with a 9. My eyes were blind. Okay, so we have 3 of them now with a 4 in the hundredths, tenths, and the thousandths. So this was the one with a 9 coming after that. The others, this one also. So 9-0 or 9-1, the 9-1 is going to win. So that one with the 1 as opposed to that one, 0 and a 5. And the last one was the 1, the 2 instead of a 4. Okay, everyone happy? Okay, good, good. Let's get to something more interesting. Okay, now that we have our vocabulary, I can talk about thousandths and so on, and everyone knows what I'm saying. Then sometimes we really care. So if you wanted to, you could click here and see a fun thing about somebody that had to measure things to the millionths place. So is that really true? Can you see when I move my mouse cursor here? Even if I'm not. Again, when I wiggled the mouse, could people see that, or is that too hard to see?
Yeah, it's small, but you can see it.
Small that I can see it. Okay, I wish I had a better way to do that. Anyway, can I annotate when I am sharing screen? Screen. Should be some way to annotate, but I don't have it. Anyway, so the 7 was tenths, 1 was hundredths, 4 was thousandths. That means the 2 is 10 thousandths. The 8 would be 100 thousandths, and the 6 is indeed millionths. So, okay. Usually when we get long decimals, it's not because we are measuring something so incredibly carefully. It's because we've done division. Division makes lots of fake accuracy. So number 5, if I'm planning my kid's birthday party, there's 6 kids attending, so I need 7 party favor bags because my own kid needs one. If I have 40 pieces of candy, how many go in each of the 7 bags? And I can do 40 divided by 7 and get this long thing. but I'm not going to put something with a millionths place of accuracy in a party favor bag, right? In this case, no, I'm going to give each kid 5 pieces and I eat the rest because they don't get partial pieces. A situation with slightly more accuracy is there's a pharmacist. The label says 40 milligrams. And they aren't sure exactly how accurate that is. Is it 35.5 rounded up? Is it 40 measured very carefully? Who knows? She's going to divide that into 7 doses for a weekly amount. How many milligrams are in each dose? So here again, we could do 40 divided by 7 and get a long decimal. How much accuracy do you think we should use in our answer? Somebody call something out.
Complete accuracy. If it's pharmaceutical,
We would like to trust that it's accurate.
At least to the thousandths place.
At least the thousandths place, tenths, hundredths, thousands. So at least 3 decimal places. Okay, well, I happen to look things up, and a pharmacist scale itself can measure to the 10th of a milligram. That's about all they actually get. So there's 2 reasons that we would just say 5.7. One is that that's about all her scale can actually do that we can trust. And the other is that our initial number, the 40, didn't have any decimal point accuracy. Somebody could have written 40.0 if they wanted to emphasize that they actually knew it to a part of a milligram, but they didn't. So it might be 35.6. It might be 40.4. We don't know. So for both those reasons, the initial accuracy and the fact that her equipment had limitations, then adding more than 1 decimal place would just be bragging. We don't actually know it to more accuracy than that. So one of our big lessons then is our tools matter. Whether we're doing laser surgery or carpentry, we have different tools. The accuracy we have matters. So the context will tell us how much to round more than just the math rule. So carpenter, 40-inch board, it's the same thing. We're doing 40 divided by 7. How accurate do you think you can be with a board and a saw? We're talking about inches, by the way. Everyone's quiet. No one wants to.
Say the hundredths.
Hundredths, yeah. If you're not good at carpentry, maybe tenths of an inch is pretty easy. If you really know what you're doing, with a home setup, you could do hundredths of an inch. Okay, so our general rule is trust your equipment and also use the same number of decimal places as in the original value, or perhaps 1 more. Because when we make small piles, then we actually can be a little accurate. We just can't be always as accurate as we want. Okay, rounding is when we reduce the accuracy on purpose. That's kind of strange. Why would we want to reduce accuracy? It's usually because we had too much to start with because it was fake, like we just talked about. We're going to pick the decimal place, make everything to the right of that 0, and then of the ones we just zeroed out, check to see if the largest, the leftmost, was 5 or more. And if so, we take the one that we're rounding to and bump it up by 1. So, whoops, I can't copy and paste that way. I do that. Let's not worry about thousands yet. Okay, again, I'm checking in. Is this big enough to read for everyone when I was having those things on the board? Yes, holler if it's not. Okay, so I want to round 4,573.1. Let's start to the nearest ones. So Following that procedure I just said, I look at the ones, and I also look at just to the right of that, the biggest of the things I'm about to get rid of. Is this number 5 or more? No. So the 3 stays the same. And I can just zero out things. Should I write 0.0? It doesn't matter. In fact, it says to round to the nearest ones. So writing the 0.0 would be kind of strange, but I wouldn't mark it wrong. Okay, same problem. Now we are asked to round to the nearest tens. So I might pick a different color. So I look at my tens. I look at the one that's just to the right of that. The biggest of the ones I'm about to zero out. Is 3 5 or more? No, so the 7 can stay the way it is. Last one. So I look at the number that they tell me, hundreds. I look at the one just to the right of it, the biggest of the ones I'm about to wipe out. Is 7 5 or more? In this case, yes. So I have to take the 6 and make it be bigger because of the 7. Okay, everyone happy with that? Good, old review. Let's do one with decimals and say good enough for review of that. Okay, so 1.95283. So start with tenths. So here's my tenths. I look at the one just to the right of it, exactly the same. These are all about to become 0. Is 5 5 or more? Yes, it is. Oh, I should keep that color. So I want to make the 9 into a 10. Of course, I can't do that. What do I do?
Add it to the 1.
Change the one.
Yeah, I have to carry. So this is going to be 2.0. Now, can I write more zeros after this? I could. Doesn't really matter. I've rounded to the nearest 10. Okay, hundredths, tenths, hundredths, and the thing to the right of it, hundredths, hundredths. Right? Okay, am I looking at the 5 or the 2? Which one do I care about right now?
The 2.
The 2, and the 2 is not 5 or more, so it's just going to become a 0. We're going to just get rid of those. Thousandths, tenths, hundredths, thousandths. Look at the one to the right of it. Is 8 5 or more? Yes, so that one's going to get bigger. And I should have.
You can ask him.
I don't want to play Mario Kart.
Okay, stop share. Everyone happy with rounding? Okay. As you can tell, the first day of class, nothing terribly exciting happens because in any term, there's always people who join late. So I have to do something worthwhile, but I also have to not do anything that's terrible if you miss it. Impossible to do well. Okay, moving onward. Your turn. So you think you know what's happening. I guess I can copy this. So tell me, where's the rounding error in my problem? If you're quick, type it in chat so you don't spoil it for people. So for hundreds, I would look at the hundreds. That was a bad circle. I would look at the hundreds. And then I would also look at what's next to it. Is 7 5 or more? Yes, so the 4 would become a 5. So hundreds is done correctly. Thousands, someone suggested. Yes, for the thousands, I would look at my thousands, which right now is nothing. It's like there's a 0 hiding there. Is 4 5 or more? No. So I would keep my 0 the same. So when I'm rounding to the thousands, I should just say it's 0. It's less than 500. It's closer to 0 than it is to 1,000. So it rounds to 0 thousandths. Okay. An interesting thing to do is see how much rounding in the middle of a problem messes us up. I keep highlighting it because that's what I'm used to doing in the classroom. So if it rains 1.15 inches per week, how many weeks are in a year? I'm going to multiply it by 52. Then if I was to do this without rounding, then we'll get to 59.8. If I was to round first, we'll in just a moment say this is estimating. I can say 1.15 is about 1. And if I do 1 times 52, then I only get 52 inches. So I have different answers. Rounding in the beginning changes things. Not a surprise there. If I do math with different numbers, I get different answers. But I want to point that out because your textbook and probably other math classes have asked you to estimate, to round a problem at the beginning. So rounding at the beginning is estimating. So why would we do that if it breaks our problem? Somebody chime in. Why would we ever estimate?
To just give us like a quick educated guess.
Yeah, sometimes
Simplify?
that's what you want. Go on.
I said to simplify.
To simplify? Simplifying is usually at the end. You take a fraction or something that's complicated and write it in a nicer way.
Okay.
So,
I want to be able to bring enough money to dinner when I pay.
yeah, sometimes it's good enough, right? If I want to make sure I get enough 20s out of the ATM machine, then if I have an extra one, it's not the end of the world. The calculator is a big deal too. That sometimes when you're using the calculator, especially in a longer problem, we just hit the keys badly. And if we can estimate mentally, and in just a moment, say the answer is supposed to be like about 5,000, and we get 5 million, then we know I must have hit the keys wrong. Whereas if we get 6,000, we can say, okay, I can trust that I did my calculator math okay. But the secret answer is that you really almost never estimate by choice. That this is all just a bunch of baloney that is done in a math class. That in real life, you are estimating because you're forced to. You're planning a road trip and you want to know the cost of gas, but every gas station will have a different cost of gas. We just have to pick some number and go with it. We're trying to make a budget for food, but how much whatever, canned salmon costs varies from week to week when we go shopping. So we're just going to write a number down and pretend it's the right one, and so on. So we estimate because real life is like that. We have to. We don't have consistent, accurate numbers to use. And if you're interested in that, whoops, I need to share my screen. Then in our playgrounds, one of the playgrounds is error propagation. And so if you click on here, and you can fill in numbers in these spots, it guides you through that, and see how badly it changes things. And play around and see which operations for plus, minus, times, or divide make the most errors when you estimate and things like that. I wouldn't jump to that today, but it's an interesting to think about, is when is estimating terrible? So I'm going to skip over estimating for now. Ask me next class if you need me to do more estimating, but we just did a bunch of rounding and I want to get to something more interesting. Okay, I will check in. Any other things about place value or rounding that you have questions now? No. Okay, I'm going to, since we're nearing the end of the hour, not that it's a 1 hour class, but I'm remembering to take attendance. So let me do that. So Chrissy's here. Actually, just say something in chat. If you haven't said something in chat yet, do that. And then I'll know everyone is here because I can look at the chat later. That will be easier. If you've already said anything, good enough. Okay, so thank you. Okay, fractions. My warning before fractions is that fraction math is the least favorite part of math for lots of people. So if you're thinking, ugh, fractions, that's normal. And if you are needing to be brave, then good, we will be brave. So I'm not going to say fractions are friendlier than you think they are, but I am going to say that for most people, the reason fractions are hard is that they haven't been taught about things the right way. So part of my job in the beginning of Math 20 is to go back and try and teach you the right way to think about things. And since fractions are about division, then we have to start with division. So if you have in front of you 6 pieces of paper or things like that, that would be good. I'm going to go run and get mine. So find little 6 things you can destroy, not important things like playing cards. So pause, do that. If you need a quick bathroom break, do that. We'll get back in like 3 minutes. I was sloppy and should have paused the recording back on. Okay, sorry, the recording now missed some fun stuff about piles, but oh well. Okay, let's do this one. So if I was to do 4 divided by 1/2, imagine you have 4 tickets. You make piles of size 1/2. How many piles will you get when you're done?
8.
8.
8.
I'll try drawing it this time instead of using my paper tickets. So I have 4 tickets. I'm going to cut each one in half. Then how many halves do I actually have?
8.
8.
8. If I stop share, I can destroy more things. Why not? If it helps somebody, since I was not recording, maybe someone that's watching this later will like it. So I have my 4 tickets. I don't want to make piles of size 1, so I have to rip each one in half. And then I can look carefully here and see, I have 8 different piles of size 1/2. If I wanted to, I could do it the old-fashioned way. Take the 4, turn it into a 4/1. To divide by a fraction, we flip and multiply. 4 times 2 is 8 going across. 1 times 1 is 1 going across. And 8/1 is 8. But you don't need to do all that. Okay, trickier one. If I have 1/2 and I want to divide that by, did I just make an extra dot? I did. I want to do 1/2 divided by 1/4. How would I do that? I could take half a ticket and I want to make piles of size 1/4. So with your half paper or whatever you are destroying in front of you, then how many quarters do you get from your half an object?
2.
2. So if I put each of them in their own pile, how many do I get? So is this going to turn into 2 the old-fashioned way also? Four times 1 is 4 going across the top. 2 times 1 is 2 going across the bottom. Now I need to reduce. Two over 1 is just 2. So it matches. It's just a lot more work than thinking about it carefully. Okay, questions about all of that?
Nope.
You won't ever actually have to do that on a test or homework, but you are well-educated people. You deserve to know how to think about fractions in more than one way. Okay, back to our lecture. Okay, before we play with fractions too much, we need to be able to play with factors. So factors are the numbers you multiply to get to another number. That's kind of a sloppy way of saying it, but it works. 3 and 5 are factors of 15 because 3 times 5 is 15. 1 and 15 are factors of 15 because 1 times 15 is 15. And if you've never seen it before, it might be nice to think about factors by how to make rectangles with blocks or something. So what are the factors of 12? I could do 1 times 12 at the top. I could do 2 times 6 on the right. Or I could do 3 times 4 on the left, or I could do 3 times 4 on the right. So all the ways you can make rectangles gives us the factors of a number. Okay so far?
Yeah.
Holler if I'm going too fast. So just like people were too often only taught one kind of division, people are too often only taught one kind of, or a limited amount of divisibility checks. So you probably already know these 3 at the bottom of my screen. A number is divisible by 2 if it's even, and by that we mean the ones digit is 0, 2, 4, 6, or 8. A number is divisible by 5 if its ones digit is 0 or 5, and a number is divisible by 10 if it ends in 0. most people who get to Math 20 have never been taught about these other rules, which aren't any harder. It's just through no fault of your own, no one has told you. So let's look at those. I'm going to put those rules on my screen. And I'm also going to, oops, that's right, I have to do it. Okay, so our number that we care about is 13,512. Is this going to be divisible by 2?
Yes.
Yes, it ends in 2. It's even. We're happy with that. Is it going to be divisible by 3? That one we might have to do a new check for. So to check if something is divisible by 3, we add up its digits. So 1 plus 3 is 4, plus 5 more is 9, plus 1 more is 10, plus 2 more is 12. Then we ask, does 3 go into 12? Yes. So 3 goes into our original number also. Okay, is this big number divisible by 4? It's divisible by 4 if when I just look at the 1s and 10s, 4 goes into that. So does 4 go into 12?
Yes.
Yes, so 4 goes into our big thing also. 5, does it end in 0 or 5? No. 6, well, if 2 and 3 both work, 6 will work. So 2 and 3 both work, so 6 works. 9 is similar to 3. We add up the digits, and then we check. Does 9 go into 12?
Not
No.
evenly.
No, it doesn't. So it's not going to go into our big number either. Okay, everyone okay with the extra divisibility rules that you might not have seen before?
Yeah.
Yep.
Yeah, let's do another one. I don't trust you. Okay. Okay, 5, 6, 6, 1. I know that eventually I have to add up these digits. Let's just get that done. So 5 plus 6 plus 6 plus 1. 5 and 6 is 11. 6 more, 17. 1 more, 18. Okay, is this divisible by 2?
Yes.
Yes. No, it ends in 1.
No.
Oh.
So odd number, not divisible by 2. Is it divisible by 3? We look at the sum of the digits. Does
Yep.
3 go into 18?
Yes.
Yes, so 3 is going to go into this big number too. Okay, 4. If I look just at the last two, does 4 go into 61? No, 4 doesn't go into any odd numbers, so that's going to be a no. 5, does it end in 0 or 5?
No.
Nope.
No. 6, do 2 and 3 both work?
No.
No,
No.
because 2 didn't. 9, does 9 go into the sum of the digits?
Yes.
Yes,
Yes.
so 9 is going to go into this big thing we started with also. Why do we care about divisibility rules? What use are they in Math 20?
So you got to know how to do divisibility to do fractions?
Yeah, it's when we want to reduce fractions. Often we can just sort of whittle away, divide by 2 top and bottom again and again. It's boring, but it works. But sometimes if we want to be more efficient, we can say, oh, look, 9 goes into the top and bottom, and so on. So, okay, what else to talk about? Factor game. I have to shrink a little so that you can see it all at once. So if we want to review having factors, the most fun way to do this is the factor game. Let me stop the share for a moment and just sort of, now I have no idea in Zoom if you're in the same order to each other as it looks to me. So I sort of see Chrissy, Devin, Madison, Christina, Crystal, Spring. Is that the same order everyone else sees? No, I didn't think so. Okay. So looks like, let's see, C's 1, 2, 3, 4. So it looks like if your name starts with D or earlier, then you're on one team. So that's Chrissy's and Christina's and Devin and Anna. And Debbie. And if your name starts with E or later, then you're on another team. So how this game works is, whoops, you are going to team 1 will claim any square they want that's not claimed already. And then in response to that, the second team gets all of the unclaimed factors. And if they miss any, then the first team gets to go ha and get those. But people never miss any in a team game. And then you switch. The other team gets to pick anything they want. And then the other team responds to that and takes the factors. So the beginning of the alphabet team, which number do you want for your first thing? And the score at the end would be your total number of total of all the numbers you claim. So claiming 25 is better than claiming 1 just because you get more points at the end. But you don't want to give people factors needlessly. So shout things out.
I think I'm confused. I don't really understand what we're just choosing a number.
Yeah, choose a number if your name starts with D or earlier.
16.
16. Everyone else happy with
Yeah.
that if you're early in the thing?
Yeah.
Yeah, okay. So if the early team gets 16, then the other team, people whose names start with E or later, get all the factors of that aren't claimed. So what will they get? Will they get
2.
1?
1.
2. 2 is a factor of 16. 2 times 8. 1. 1 times 16.
4.
4. 4 times 4.
8.
8. 8 times 2. So at the end of that round, the first team got 16 points. The other team got a total of 15. So there we go. See how that kind of part works? Now it's the green team's turn to start. So pick any number you want.
21.
21. Everyone else on the green team happy with that?
Yeah.
Okay, the early alphabet team.
7.
You get 7. 7 times 3 is 21.
3.
And 3, because 7 times 3 is 21. 1 is a factor of 21, but it's claimed already, so we don't get that. Okay, that's all the other factors that aren't claimed. Okay, back to the circle team, the blue team. Pick anything you want. It's your turn to start instead of
25.
25. Everyone happy if you're on her team?
Is it
23?
23. I hear 2 suggestions, so pick one.
23?
23. Okay, does the green team get anything?
Nope.
No, the only factors of 23 are 1 in itself. There was a special name for those. Who remembers that?
Prime.
Prime, it's a prime number. Okay, so they don't get to reply. So now it's the green teams, the higher letters, but just to pick whatever you want. It's your turn to start.
29.
29. Everyone happy with your teammate's suggestion?
Yep.
Okay. Does the blue team get anything in response? No, it's prime. If you weren't sure, you might add up the digits and things to check for divisibility by 3 and 9. Okay.
They don't get the points if it's already taken, if the numbers are already taken, right?
Right. So, okay, blue team, how do you want to start?
25.
25?
5.
So then the other team gets 5, because 5 times 5 is 25. But still, the blue team's ahead by 20 points with that play. That's good. Okay, green team's turn to start.
22.
22. It looks like Justin's trying to talk, but he's muted.
22 and 11.
22. So yes, if green gets 22, then blue can reply and get 11, which is still a net gain for green. Okay, blue, your turn to start.
13.
13. Everyone happy with that?
Yes.
Yes.
Okay, so 13 is prime, 1 is taken, green doesn't get anything. Green, your turn to start.
24.
24.
12.
12. I hear a few different ideas.
12 and 6.
If green picks 12, blue gets 6, which is only a 6-point gain. There might be a better play than that.
14.
What was that?
14.
14. So if green gets 14, 7 and 2 are already taken. So no reply there. Okay, blue.
19.
19. 19 is prime, so no response. Green, you get to start anywhere you want.
17.
17. 17 is also prime, so no response from blue.
26.
26. Okay, what are the factors of 26?
2 and 6.
6 doesn't go into 26. 6 times 4 is 24. So 13 times 2, but those are taken already. So 26 was a good play. Okay, green's turn.
24.
24.
28.
So 6 times 4 is 24. 6 you get. 4 was already taken. What
And
else?
12.
And 12. Yes, 12 times 2 is 24. Okay, blue, your turn to start wherever you want.
9.
9. So 3 times 3 is 9, but 3 is taken already. Green, your turn to start wherever you want.
28.
28. 28 is a good play now. 14 times 2 would work, but those are already taken. 7 times 4 would work, but those are already taken. So that would be a terrible play in the beginning of the game, but right now that's great. Whoops, but I made you the wrong symbol. Okay. Blue, your turn to start wherever you want.
27.
Okay. What are the factors of 27?
1 and 27. 9.
1 and 27, 9 and 3. And that's one. So all those are taken. Green, you start wherever you want.
18.
30.
Which is a better play? Talk about it, Green.
18.
If they did 30, they would only come out ahead by a little bit because blue would get 10 and 15 for 25 points. Whereas if they pick 18, there's no replies happening, so they get ahead by 18 points. Okay, blue, you start.
15.
15. Okay, no replies. Green, you start.
20.
Green for 20. So green gets 20, blue gets 10 in reply, and then new turn, blue gets to pick whatever they want, and there's only one choice. Okay, I'm guessing if we added this up, blue would be ahead just because they have a little more in the bottom row, but there we go. If you need something to play to review multiplication, if you have kids that are doing multiplication tables, here is a fun game for you. Okay, the game you usually see in a math class is something that looks like this, a factor tree, but we're not going to get there quite yet. We're going to first say, what are all the factors of 66? And the way to do that is to make like a horseshoe shape. We start and say, well, 1 and 66 are factors of each other. Does 2 work?
Mm-hmm.
Sure, 2 times 33. Does 3 work?
Mm-hmm.
Sure, 3 times 22. Does 4 work? No. Does 5 work? No. Does 6 work? Sure, 6 and 11. Does 7 work? No. 8, no. 9, no. 10, no. And now we're back to 11, and we can stop. If there were any factors bigger than 11, they would need a small thing to match up with. They would already be on our horseshoe shape. So that's a game you might not have seen before, but that's to find all the factors of a number. This is famously called the marching band problem. If you had 66 people in a marching band, how could you line them up? You could do 1 row of 66, you could do 66 single file. You could do 2 rows of 33, you could do 33 pairs. You could do 3 rows of 22, you could do 22 rows of 3. You could do 6 rows of 11, you could do 11 rows of 6. So finding all the factors has a few real life applications, but it's not one that's taught quite as often. What you have seen more is factor trees. And notice this doesn't find all the factors. 12 is a factor of 48, but there's no 12 on this factor tree. I could make a different factor tree of 48 that started with 12. How would I keep going?
Two times 6.
I can do 2 times 6 over here. And I heard 4 is 2 times 2. 6 is 2 times 3. Now the danger with factor trees, what I'm about to write is that 48 is 2 times 2 times 2 times 2 times 3. And I see it all the time on homework and tests, especially on tests when our brains tend to turn off, that people make the tree correctly and then they just forget one of these numbers. So there's 2 techniques to this. One is once you get done, circle all the leaves on your tree so that when you write your answer, you don't forget any of them. The other technique is to, if something doesn't go all the way down to the bottom, just keep pulling it straight down. Whatever makes you happier, but those are 2 different techniques for how to not skip any numbers at the end just by careless stuff.
How come you didn't put the 4 and the 12 and the 6 in there?
The 4 and the 12, because I'm wanting a prime factorization. So let me,
Okay, gotcha.
I may take a step back. So the reason we do this is to find prime factors. I'll talk about why in a moment, but that's what this does. It just keeps going down and down and down. Since this example has the lines, I'm actually going to go back and do the leaves so that people watching in the lecture can get both versions of the tip. But the whole purpose of this is to keep drilling down till we have only prime numbers left. Again, I'm not telling you why yet, but soon. So let's do another one. How about 80? I have lots of ways to start. What should I do?
10 times 8.
10 times 8. Okay. Now, am I allowed for 8 to make like a 2 times 2 times 2 and have 3 things come out of a number?
They're
Sure.
all factors.
Yeah, as long I can. That might not be what I normally do, but if I wanted to, I could. I'm guessing people would feel more happier if I did 2 times 4 and then broke up the 4. But it all works. Okay, I'm not done. This 10 needs dealing with.
5 times
2
2.
times 5.
Yeah, 2 times 5, 5 times 2. Okay, so 1, 2, 3, 4 2s and a 5. So those look a little more like multiplication dots. If you are fancy and like exponents, then you could also write this as 2 to the 4th times 5, but I don't care if you're fancy or not. Either one is good. Just like in the previous one, if you wanted to, you could write this as 2 to the 4th times 3, and that's good too. You don't have to either way. Okay, should we do another?
Sure.
Yes.
Sure. How about, some of them are pretty quick. So 49. What will I start with?
7 times 7.
7 times 7, and then I'm done. That's all there is to this one. Okay, 51. So if you're not used to divisibility tricks, you might wonder, is this prime or not? But I add up the digits and get to 6. So I know 3 goes into it. Calculators are okay. What else? What's the other factor? Yeah, 17.
17.
So I am done. Those are now both prime. So once again, factor trees get all the prime numbers. They don't get every factor. So this one, I could have had 20 as a factor, but there's no 20 on the screen right now. If you want all the factors, you have to go back to that horseshoe game that we did before. Okay. Should I dive in or not? We stop at 11:50, right?
Yep.
Yeah, okay, I can keep going. Okay, actually, I'm going to pause the share and just check in where I can see everyone's faces, because this has been a lot of stuff so far. Anything you want me to do more of? Anything you have questions about? Anything you have an easier way from another class that you want me to talk about?
Not at the moment.
Everyone good? Okay, then I will keep sharing. So if I want a fraction to have a certain denominator, then I can do that somewhat. If I have this cake 1/3 of my cake is selected. How could I make it into sixths instead of thirds?
Cut it in half.
Cut it in half, yeah. I can just say, if I make a cut there, forgive my lousy artwork, now I have 6 pieces. And of those, whoops. No. What happened now? There we go. 2 of them are shaded. So I've just sort of done with a cake cutting that 1 out of 3 being shaded is the same as 2 of my 6 being shaded. Hopefully this is old review, but for visual people, this is nice. You're never required to draw a cake on your homework for your tests, but for some people, the pictures helps. For others, it's an annoying distraction. So if this doesn't help you, tune out. If I wanted to make ninths, I could do that too. Is it only letting me do 20? That's annoying. Then I will make a copy. Pardon me, unexpected technical thing. Probius is in charge of tech support for me. He should have warned me. I should also save it as a PDF while I'm waiting. Here, I'm going to stop the share just in case that's using a lot of bandwidth. I didn't think our whiteboard was going to run out of room. And I'm getting a Google Drive error. Well, I have backup plans. Who is watching along on the Jamboard? Raise your hand or wave or something so I can see who is. A few people. So if I do something that's not public on the internet, it will be a little bit annoying. Okay, yay, I have a copy there. Is it going to let me save it also? I don't trust it at all. Okay, so yes, I can see it in the drive. It is there. Okay, we can keep going. So I'm just going to like erase everything. We have it saved for posterity. Thank you for your patience. I can always start out next class with 2 of these ready instead of 1, so that we don't have to worry since we aren't going to make 40 slides. Okay, what was I doing? Trying to make ninths. So how would I make this into ninths?
Divide by 3.
Divide by 3, yeah. If I cut everything into 3 pieces, that's terrible drawing. Anyway, now there's 9, 3 of them are shaded. So 3/9 and the 1/3 we had are the same. So most of what you're asked to do in a math class is not what I'm calling unreducing here, taking a number that has smaller top and bottom fraction and make it with bigger numbers on the top and bottom. Normally we go the other direction. We make things have the smaller numbers. So that would be reducing. Reducing would be the same thing, except I hit undo. I'm erasing the lines across the middle of my cake. So instead of 3/9, I'm back to 1/3. Again, for some people, the pictures help. For other people, it makes it annoying. I want to talk about this part, though, because this is where things actually matter for writing. If I want to write that I am going from 1/3 into 3/9, I could write 2 little floating multiplication things. And multiplying the top and bottom by 3. That works. That's great. That's how I'll normally do it. I could write 1 fraction. I am multiplying this by 3/3. And that also works. Many fewer people would want to write it this way, but there's nothing wrong with this at all. And some people really like canceling. So even though there's no canceling happen, they're going to write this as if it's canceling and do a ×3 top and bottom and do things that way. And that I can still see what's happening, even if it's kind of bizarre because it's not canceling. So all 3 of those are good. What you don't want to do is just write 1 times 3 in the middle, because that means something different. Because 3 is actually 3/1, so this would be 3/3, which is different than 3/9. So you can't write unreducing with just a single thing in the middle. If you don't have any habits, then I would pick this one as a habit to teach yourself. Similarly, if I am reducing my fraction, if I'm going from 3/9 to 1/3, you could have a little divided by 3 top and bottom. That's great. You could have a divided by 3/3. That's great. You could write it like canceling. That's great. But what you can't do is just put a divided by 3 right here, because that means something different. That means divided by 3/1, which would get you a different answer of 3/27. And as before, if you don't have any of those habits, then I would stick with this one if you are teaching yourself a new habit. Okay, questions about that, how to write things nicely?
Nope.
No, you are all stunned and need lunch. Okay. So our definitions, we reduce a fraction by dividing the numerator and denominator by the same value. And of course it has to be a factor or we're going to make a mess. And a fraction is fully reduced if they don't have any numerator or denominator, don't have any factors in common anymore except 1. Many books and websites will use the word simplified, but I avoid that because people tend to say like simplify, which means just do this. And you're supposed to read the mind of the instructor or the textbook and know what you're supposed to do. So I will use simplified as seldom as possible because I'm not asking you to be mind readers. Okay, let's reduce 8/24. how should we reduce that one?
Divided by 8.
Yeah, some people will whittle this away and do divided by 2 several times. There's nothing wrong with that. If that is you, it works, you are happy. If you can see that 8 works, you can get it done in one step and not have to keep going. So
I can't see what you're writing, by the way.
Oh, I didn't put share screen back on. Thank you for letting me know. Share screen. There we go. Good interruption. So, yep, I did divided by 8 because that's what someone told me to do. If someone had said, I want to whittle away at this a little bit at a time, and that also works. It takes longer, but who cares? So if you are a slow, methodical, little bit at a time person, it still is good. You still get the same answer. Okay. The greatest common factor is the biggest factor that they both have. That's just what the greatest means, right? So if you can see the greatest common factor, in this case 8, you can get it done in one step. If you don't, any factor will work. You will just have to keep going. Okay, I'll save this one for Wednesday. If you haven't tried it, then you'll miss out, but do that. Okay, now we really should stop with new stuff. There are videos after different subsections. If what I've done isn't enough, then you can do that. It's also true that every time we have a subsection, there's those links, not links, orangey numbers at the top. So if desired denominators, reducing and unreducing was confusing and you want more practice, or if you want to jump to the textbook problems, then in the pre-algebra, that's the online one, go to page 145. And you can see all of this stuff. This book is nice because all of the problems have people doing videos. Ah, you're loud. Okay. But yeah, you can scroll down here. Come on. No. And see all the example problem videos, or you could just click on the thing that says video right next to them. It has homework problems at the end, and the odd thing is to get to your example answers, and I'm sorry, to get the homework answers, you have to click supplements, and the odd numbered answers are there. So it's not quite as easy. On the other hand, if you have the blue book, the basic mathematics, then I would take my blue book and go to section 2.5 and find more example problems and more homework problems there. So anything we've done today, you can go and see, here's the places to go to get more help with it. Again, after class, then look through the example problems. There's lots that we skipped on the website as we went down the page. Try those, see if you can do them with or without peeking at the answers. You can find the best homework for the blue book. Just what past experience has shown all the Math 20 teachers together that this is probably enough homework. You can do the homework in the new book if that's what book you have. And then you can do some problems there once they get going. The random problems are what we do tests on. So you can say, we have done rounding and shape shifting. Here's some rounding problems. It has answers, so you can see if you're doing it right. And every time you reload this page, the problems change a little bit. So you get as much practice as you want. Now, how do you turn in your homework? You turn in your homework by saying, I'm doing shape-shifting rounding. Here's 10 problems. And I would love it if I could pass out this on paper to you. If you can print at home, then I would just unfold all of these things and print them for the first section. because it's really much nicer to do homework on paper in front of you. But if you can't, that's okay. You can just stare at the screen, maybe have a tablet off to the side or something, and see all the homework problems. Once you've done them all, it says click here. Everyone see where I'm highlighting? So at the bottom of each of the 10 homework problems for a topic, it says click here. And when you do that, it brings you to a page with multiple choice answers. So you're going to just pick a bunch of them. I will just do the first for all of them to be doing something. And then at the very bottom, it says process my answers. I click on that and it gives me a code. Copy and paste that code into an email or a text and send it to me. And I will get back to you and say, great job, 8 out of 10, you're done. Or good start, 6 out of 10, keep going, or something like that. You can try this as many times as you want, and practice is good. So the flow, again, is that start for a while with just looking at the example problems. Do the ones in the book. Once the example problems make sense to you, try a few random ones. And then finally, as the icing on the cake, turn the ones in that need to be turned in. Okay, I'm gonna stop my share. Questions about your homework process?
No.
No.
We start that now.
Start that whenever you have time, right? That's a good question. The detailed answer is at the bottom of this homework page, it talks about your levels of math understanding, and do prompt homework problems promptly. These are for time management. Just do a few of each of the things we've talked about, the rounding and the beginning of fractions, and see if this is something that's going to take a lot of time during the next week or something that's all review and you can do very quickly. So I would prioritize that. I would be kind of nervous if I had dinner or went to bed without having done any homework just to know how hard it is for me. The enough homework problems is the LCC nickname for when you actually do a bunch of them to get mastery of the math topics. So those, if you need to wait a little bit because we have jobs and kids and stuff, that's understandable. It might be Tuesday or Wednesday before you even really sit down to do homework for more than a few minutes. So do a little bit promptly, figure out if this is going to be a big homework week for you or not, and then do enough when you have time. That answer your question?
When is homework due?
When is homework due? That's a good question. So someone typed in chat, how many are we doing? All homework assignments are 10 problems, just the 10 problems for rounding or whatever it was, right? Going back into here, you have 10 problems for rounding, 10 problems for fractions, but we haven't finished talking about fractions like that. When are they due? When we meet on Wednesday, I will start by saying, does anyone have questions about rounding? Maybe you will from the example problems, from either of the textbooks, from this homework, because you've actually gotten this far somehow, whatever. So I'm sure on Wednesday, people will have questions about rounding in some way or another. Whatever day it is that no one has questions finally, maybe Friday of this week, no one will have questions about rounding, then homework will be due the day after that, the class after that. So if no one has questions on rounding on Friday, they'll be due on Monday. Actually, we don't meet Friday, do we?
No, we don't.
We don't. So, okay. So if no one has questions a week from today on Monday, then they will be due Wednesday of next week, the class after that. So nothing is due until people run out of questions, and then it's due the next time.
So is doing the 10 questions for every category just kind of at your own pace then?
Yes.
Okay.
The study sessions, let me go back and look at that. So we picked Monday, noon to 1, Tuesday, 2 to 3, and Friday, 3:30 to 4:30. And if people need more than that, let me know.
You have to go to those because
You don't have to. They are
Okay.
just optional. But it's much nicer to do homework with groups. And so, Unlike
just
today, where I was mostly talking, this will just be everyone has their microphone open, work together, do lots of homework.
Can you repeat those group times again?
Yes, Monday, I'll type them in chat too. Monday, noon to 1 p.m. Tuesday, 2 to 3 p.m. And Friday, 3:30 to 4 p.m.
And do we get to that by just coming in and just going into Zoom like we did to come into the class?
Yep, if you're the first one here, then it'll just be you. I'll show up hopefully on time, and other people, we can all be unmuted a lot more, and you can work on things together. None of the homework needs to be done by yourself. So you will learn more talking about it than trying to be a lone ranger. But if you have jobs and kids, then sometimes we just have to work on homework by ourselves. If we were in grad school, there'd be almost no one who ever does homework by themselves. It's less efficient.
David, I just wanted to say thank you for all the work you've put into making this class possible like this. I really appreciate it. And yeah, this has been a pretty awesome experience just doing this one class. So thank you.
You're welcome. I hope it was smooth and legible. Complain to me if it's not. And there's a lot on the website you don't care about yet. So as that email said, there'll be projects we do. There'll be lots of things that aren't sort of boring math that's from the textbook, but I'm not going to overwhelm you yet with all the fun stuff. So we just did the boring thing that looks like the most of the textbook and the kind of math you've done before. And there's more to Math 20 than that, but we can wait and break our way in slowly. So explore the website, but if all you do is look at topics and homework before Wednesday, that's plenty. Okay, anything else?
No.
No.
Okay, I'm gonna go check in on my kids real briefly, but not really leave. I'm going to stop the recording, however.
We're safe to leave.